So let's take a deep dive into registers, and let me create a new file, a new assembly file. I'll be using nano as usual. I name it main.s. Then as usual we'll be writing our code here. So as you have seen in the previous videos, assembly expect us to write our source code inside the text section. So you define the section, then define the global entry point. This is the main function. Then you start writing your code. So in the previous videos we have seen some registers. We have seen registers like, so let me change something. We have seen registers like the EAX register, EBX register, ECX registers, EDX. So this is what we call the 32. These registers are 32-bit long, meaning they can only handle data or can only hold binary digits which are 32 bits or 32 bits in size. So these are the 32 bits. So there is the 16 bits, the 16-bit registers. So and they start like this. So there is a AX, BX, no, so BX, CX, and DX. So these are 16-bit registers, so they can handle 16 bits worth of data at a time. Then we have the 8-bit ones, so 8-bit. So we have seen the AL, BL, CL, DL. So these are the registers that you can use to manipulate. So these are 32-bit registers, 16-bit registers, 8-bit registers. So you can go ahead and play around with them. So we can start with the 32-bit one. So as usual, let us move some values. So move something like from to AX, we can move the value 12 maybe. Then after moving that, we can also move some data inside the EBX. So maybe value like 400. Then move ECX, the register some data in ECX, maybe 500. Then we will move EDX. Sorry, so EDX, the value of maybe 1000. Now, and let us put an interrupt here, so 80H. So as you can see, assembly doesn't mind how spaces or colons or indentation. You just write your code just like that. So if I save this code and try running it, so as usual we'll be using NASM. So NASM, we define the format, an ELF32 format, followed by the name of the assembly file, followed by the output or the object file we want to generate, which will be main.o. Then after that we will link the program, so ld -m. So we'll be using ELF i386, meaning the x86 assembly format or emulator, then followed by the object file main.o, then the flag-o, followed by the executable. We name it main. So just like that, we have this executable over here. In order to see the values that we have moved, I'll be using this debugger. We'll be using this debugger, but as we go on, we'll be seeing how to print something in the standard output and getting data from the standard input. So for now we'll be using this debugger, the GNU debugger. So you just write gdb followed by the name of the executable, which is main. That then I'll go ahead and just type layout asm, then we'll make a breakpoint, so break at start, then we'll just run. So over here, let's step I, so to step one step into each instruction. So it will load the data in ECX and then go to the next one, then step I again, it loads, it goes to the next instruction, so step I again, then step I again. Now we have reached the end of the program, which is this interrupt over here, and let's see what is in each register. So as of the last video, we saw that you can use this command info registers followed by the name of the register, so EAX, like that. So you can see the value 12, so you can go ahead, inspect, so info registers, so EBX, so on and so forth. So you can use this to inspect the data inside each, register. So ECX, you can see the value 500. So let's see something. Let me quit. So I will quit and go back to our file over here. So this is 32-bit, so 32-bit registers. So for those who are not familiar with bits are either, so you can say bits, so remember the semicolon is a representation of a comment. So a bit is either a 1 or a 0. So in total, like these registers can handle 32 bits. So it can handle 32 ones, 32 zeros, or 32 both zeros and ones. Then we'll go ahead and so let's see what happens if we try to store a larger value. So I'll be using the hexadecimal format, so you just use 0x, like that. If you want to write manual binary, just use 0b followed by the bits you want, but I'll be using the hexadecimal format so that I can fill the space much faster, because one hexadecimal value is 4 bits. So let's go ahead and just type some random numbers to fill this. So this will overflow, so this is more than the register can handle. So let me save it. Then if we try to compile it, you can see we are getting a warning telling us DWORD data exits bound. So meaning like we are trying to store a larger value than the register can store. So if you try to store bigger values in which exceed those 32-bit constraint, you will be greeted by that error. So you can use even the 16-bit ones. So you can just move AX, the value 56, move BX, value of like 23, move CX, value like 160, move DX or DX, a value of maybe 200, like that. So these are the 32-bit or 16-bit, sorry, 16-bit registers. So, and then we can go ahead and just use the, and below is the 8-bit register. So maybe we can just use maybe move AL, the value of maybe 12, then move BL, value of 2, move maybe CL, the value of 4, move DL, the value of maybe 4 again, or maybe 5. So these are 8-bit registers, and they go on. Even you can have something like, so you can use small case with this instruction, but I prefer using the bigger one, the uppercase one, to represent the instruction. So these are the lower 8 bits. So, and also there is the higher 8 bits, so which are representation of AH, like that one, maybe move BH, value of 2, move maybe CH, value of 3, move DH, the value of 4. So with that, you can see, like, you can represent. So these are maybe the available registers, so that you can use to manipulate data over here. So as you can see, this is our program, and so these are just the basics of registers that are available in your x86 assembly program, so you can use it. So I wanted to clarify this concept, because in the last video I noticed that I had confused or left out some concepts, but with this I think it will cement your understanding of registers. So if you have any question, you can ask me on the comment section, and I will be able to follow up with your question. So see you on the next video.